The previous video we had discussed about the electronic configuration. In this video we are going to be talking about stability of half-filled and completely filled orbitals. Before we start that, there are a few elements that I've written down: vanadium, chromium, manganese, nickel, copper and zinc. Now the previous noble gas for all of these elements is argon, whose atomic number is 18. So we need to fill in so I'm not concerned, or rather we are not discussing about the inner or the core electrons, we are discussing about the valence electrons. So here we know that first we will be filling in the 4s orbital and then we will be filling in the 3d orbital. 2, 3 and 4. Now the atomic number for argon is 18, so the number of electrons that have to be filled up would be 18, 19, 20, 21, 22, 19, 20, 21, 22, 23. 5 more electrons are left. So the electronic configuration for such an element, that is vanadium, would be 1, 2 and 1, 2 and 3. So here we had to fill in the remaining 5 electrons, which we did just now. Now in case of chromium, obviously because the atomic number is the next one, we need to fill in 6 electrons in 4p, 4s and 3d. So 1, 2, 3, 4. Next, 4s, 3d. So here, as we know, because 1, 2, 3, 4, 5, 6, this will have 7. So 1, 2, 3, 4, 5, 6, 7. Now, in the configurations that I've written over here, one of them is wrong. You can think of the reason why, or you could guess it. Chromium, the configuration of chromium is not 4s2 and 3d4, but it is 4s1 and 3d5. So, similarly, for nickel, whose atomic number is 28, the number of electrons that have to be filled in would be 1, 2, 3, 4. So the nickel's electronic configuration in the outermost shells is 4s2, 3d, 8. So 1, 2, 3, 4, 5, 6, 7, 8. 4s, for copper, it would have 3d, 9, or rather, 1 minute, here again, you will have 3d, 10 electrons. Whereas for zinc, it's going to be full. Now, the reason this happened in case of copper and chromium is because a half-filled and a completely filled orbital is much more stable than another type of orbital. So this is because of 2 reasons. First of all, there is a symmetry. When you have a half-filled orbital, it's symmetric in nature. So because it is symmetric in nature, it automatically shows more stability. Okay, so completely filled and half-filled orbitals or subshells have symmetrical distribution of electrons, and so they are stable. So they have equal energy, but they differ in spatial distribution. Now, the shielding of one another is relatively small, and electrons are strongly attracted by the nucleus. So shielding effect is basically observed when an electron or when a shell ensures that the nuclear charge does not uh, reach, or rather come to the outer electrons properly. So there is another reason why this happens: exchange of energy. Now the stabilizing effect arises when they are in two spins. So what happens is, these electrons, let's take these electrons, they can exchange their positions, okay, and this, there is a certain amount of energy that gets released when they exchange their positions, and this can take place, the number of exchanges are maximum for a half filled and a completely filled orbital, and that is why the half filled and a completely filled orbital is more stable than any other kind of orbital. So with this we finish the chapter. The next we'll be talking about the NCERT questions. Do check it out.